Hi everybody, this is Liqo and I'm going to drive you through a cloud burst scenario faced with this technology. Let's imagine that you have a simple online shop built by several microservices where your customers can select and buy all your goods. In this demo, let's pretend your shop is hosted on your Kubernetes cluster running on-premise. But for Liqo, your cluster could be either on-prem or a public cloud, it doesn't matter actually. You are confident that your business will grow rapidly over time. So, you created a dashboard such as the one we have here to keep under control your application and to highlight, hopefully in advance, possible problems. Below, in the next rows, you can find some information about test status, the amount of pods for each deployment, and the resources still available in the cluster. By the way, you can see that our cluster is already almost full. In the third row, we have the traffic exchanged by the two Liqo clusters, that obviously is zero at the beginning, when we have only one cluster, the one on-prem, and the number of emulated users that are buying from you over time. Last, with the bottom plots, we can monitor the health of our application, the number of errors, such as HTTP 500 messages, experienced by your customers, and their average response time, which shows if pages are returned rapidly, or we are forcing your customers to wait. Now, your business is going well, with so many customers that your cluster is getting out of resources. For example, let's simulate here that you have to face a burst of users. The allocated resources were initially enough to cope with the limited number of customers. But when your customers keep growing in number, the responsiveness of the website is affected. In fact, errors are popping out and the users are feeling a very bad experience. Actually, the metrics show that the response time has increased, as well as the error rate. What's happening? Well, Kubernetes is spawning new replicas to serve the new customers, but all our computational resources in the cluster have already been used. Indeed, we can see an increasing amount of pods hanging in pending status. They cannot be scheduled because your cluster is out of resources. Here is when Liqo comes. With Liqo, we can add resources dynamically and seamlessly from any remote cluster. Let's use for example a managed cluster on Azure AKS. We just have to join this cluster by performing a Liqo peering, and after a few seconds we have a new virtual node in our local cluster that is ready to host new pods of our application. With Liqo, it's like our cluster gets bigger. So, thanks to the new resources, the Kubernetes scheduler, the vanilla scheduler by the way, automatically starts the pods that were previously in pending state. Then we can see that the average response time of the application is doing good. We are way below the target SLO and the error rate is stuck to 0. In fact, now the navigation is pleasant and smooth again. If we don't need the extra resources anymore, Liqo can unjoin the two clusters with a simple operation. Now the remote cluster is drained from all the offloaded resources and the local virtual node is deleted. Liqo is really great to transparently make our cluster bigger, adding extra resources offered by clusters of any type, managed, on-premise, at the edge, and this demo is just one of the many reasons you may like Liqo. Thanks for watching!